Example 4. Think about the following scenarios. In what unit should they be reported? Explain the reasoning. The first bullet, the rate at which water fills up a swimming pool. Well, if I take a gallon jug to the faucet and try to fill it up, I think I could probably fill it up in about 30 seconds. So my rate would be about 2 gallons per minute. So if I'm talking about a really small pool, I might use the units of gallons per minute. And if I'm talking about a large pool, I might use gallons per hour. Second bullet, the cost of tiling a kitchen floor. Well, when I think of the kitchen floor, I think of the size of the floor in square feet. So I would use dollars per square foot. The third bullet, the average speed of a falling object. Well, if I took a quarter and I held it out and I dropped it, I think I could describe it as dropping in feet per second. Fourth bullet, the rate at which a snail travels across a sidewalk. Well, snails travel rather slowly, and I would think that it would travel, maybe something less than a foot per minute. So let's go feet per minute. Okay, the rate at which a room is painted. Okay, so, I think it would probably take maybe an hour or so to paint a room. So I would think square feet per hour. Example 5. Ernesto built a wooden car for a soapbox derby. He is painting the top of the car blue and the sides black. He already has enough black paint, but needs to buy blue paint. He needs to know the approximate area of the top of the car to determine the size of the container of the blue paint he should buy. He measured the length to be 9 feet 11 1/4 inches and the width to be a ½ inch less than 3 feet. What is the surface area of the top of the car? What is the most accurate area measurement Ernesto can use to buy his paint? Let's begin by drawing a schematic. So let's draw the top of this car. And, we could draw a little line here for the trunk and a line here for the hood. And the entire length is 9 feet 11 1/4 inches. And the width is 3 feet less a ½ an inch. Let's convert our dimensions to inches. So we have 9 feet 11 1/4 inches. And that is equivalent to 9 feet multiplied by 12 inches per foot plus 11 1/4 inches, giving us 108 inches plus 11.25 inches, equaling 119.25 inches. So let's go ahead and put that dimension here along the bottom length, 119.25 inches. And our width was 3 feet minus a ½ an inch. So let's convert that 3 feet to inches. So 3 feet times 12 inches per foot minus a ½ an inch, which is equal to 36 inches minus 0.5 inches, equaling 35.5 inches. Let's go ahead and put that along the left-hand side width. So we have 35.5 inches. Now our area is equivalent to width times length. So let's do a little substitution here. For our width, we have 35.5 inches. And we're going to multiply that by our length of 119.25 inches. So our area is going to equal 4,233.375 inches squared. Now, that's not the best of all units to use, so let's go ahead and convert that to feet squared. So let's take our area of 4,233.375 inches squared and multiply it by 1 foot per 144 inches squared, canceling out our units and giving us an area of approximately, so let's go ahead and make this an approximate sign, 29.4 feet squared.